Students, this is Unit 6, Polygons and Motions. Lesson 6.1, Polygons and Angles. Go to your preview notes on this page, and please note both the location that you're watching this video, the date and time, as well as make sure you get a parent, guardian, or teacher sign-off. Before we get started on this new lesson, let's do a quick recap of our most recent lesson on right triangles. We're going to be solving for all missing sides. We're not going to use a calculator. Let's take a look and ask ourselves what we have and what we need here. Have and need. We have, if that's 60 and 90, we have a 30, 60, 90 triangle, which means we should immediately put the table up. So start writing short leg, long leg, hypo. Quick recap here. Remember in the 30, 60, 90, for the hypo, it's whatever the short leg is times 2. That's the function box, times 2. And for the long leg, it's whatever the short leg is times square root of 3. So short leg times root 3. That's the 30, 60, 90 table. But take a look here. We also have a 45, 45, 90 table. So we're going to put that over here in the margin. A 45, 45, 90 table. And in a 45, 45, 90 triangle, we know that the legs are equal because it's an isosceles right triangle. And the hypo is whatever a leg is times square root of 2. Now, using these two tables, let's see what we can do here. So we are given, in a 45-45, we're given one leg here, which automatically means this leg down here is the same. So, of course, it is 12 root 2. Now, we know in a 45, 45, 90 to go from a leg to a hypo, we times by square root of 2. So let's circle this. And we're going to go and find this hypo, and we're going to times by square root of 2. And let's see what we get here. So 12 root 2 times root 2. Root 2 times root 2 is 2, so 12 times 2, that's going to be 24 here. So we have 12 root 2, 12 root 2, and 24. Now, the 24, if you look in the 30, 60, 90, that 24 is no longer the hypo, it's the long leg, which means that's the short leg and the hypo here. In the 30, 60, 90, everything goes back to the short leg. So let's start by circling the short leg. Going to the long leg, it's times by root 3. So we draw an arrow here, times by root 3. So what we have here is the short leg, so we have something times by root 3 is 24. Something times by root 3 is 24. Let's backtrack and find that something. So, of course, we need to get 3 here. So the first thing we need is a root 3, because root 3 times root 3 is 3. Now ask yourself, what times 3 is 24? The answer is 8. So our something is going to be 8 square root of 3. That's our short leg. Now, to get the hypo, we simply times by 2. So to go from here to the hypo, we times by 2. So we're going to take 8 root 3 and times by 2. And of course, only the outies talk to each other, so that's 8 times 2. And our hypo is 16 root 3. Let's take a look at our new material. In today's lesson, by the time you are done, you're going to be familiar with these words: a polygon, convex, interior angles, exterior angles, a regular polygon, and something called an n-gon. You should have on hand a calculator, colors, etc. Now, a polygon is just generic for a many-sided shape. When you see the word polygon, it's like saying, I drive a car. I'm not telling you I drive a Toyota or a BMW or Ford. I'm not telling you the specifics of the kind of a car. I'm just saying I drive a car. So polygon is generic for any many-sided shapes. So here are some more specifics. A three-sided shape, number of sides 3, of course we call that a triangle. And a four-sided shape we would call a quadrilateral. So any four-sided shape would be a quadrilateral. Now, if you're familiar with these prefixes, which some of you might know these prefixes from Latin or from science, penta is a five-sided shape. And it would be a pentagon. Hexa is a six-sided shape, and that would be a hexagon. Hepta is a seven-sided shape, so that would be a heptagon. Octa is an eight-sided shape, so that would be an octagon. Nona is a nine-sided shape, so that would be a nonagon. Deca is a 10-sided shape, and that would be a decagon. So polygon is like saying I drive a car, whereas hexagon is being more specific. It's saying I drive a Viper or a Saturn or something like that, something specific. So we're going to be talking about some specific properties about polygons today. Let's take a look at the next page. So a polygon is a many-sided shape. So if you have a many-sided shape, then you have a polygon. The word regular does not mean normal. If you say, oh, I had a regular day, it doesn't mean you have an average or a normal day. In geometry, the word regular, in reference to polygons, means if it's regular, a regular polygon is a shape that has all congruent sides and angles. So watch out for that term regular. Regular has to deal with congruent sides and angles, not normal or average. Now there's another term that you're going to come across, convex versus concave. Convex versus concave. You might remember this from in science when you study lenses. Convex lens is a lens that bulges outward. A concave lens would be a lens that caves inward. That's convex versus concave. So below we have a sample of convex polygons. All the sides bulge outward. There's no pushed-in sides. For example, this would be a convex pentagon, whereas a concave pentagon would look something like this. 1, 2, 3, 4, 5. So that does have 5 sides. 1, 2, 3, 4, 5. But it's pushed inward. It's caved inward. So that would be a concave pentagon. So all of these would be convex polygons. Now there's another term you're going to hear, and that is interior angles versus exterior. An interior angle would be all of these angles on the inside. Those would be the interior angles. And exterior angles are like this. Take one side, stretch it out. This angle on the outside, when you stretch out a side, that angle is called an exterior angle. So this would be an interior angle, and this would be an exterior angle. Now these angles, interior and exterior, have very special properties in polygons. So here, we're going to see a pattern here. In this first polygon, we're going to count. We have 1, trace with me, 2, 3, 4 sides. So our first polygon is a quadrilateral. It's a quadrilateral. It has 4 sides. Now, from one corner, I'm going to draw the maximum number of diagonals that I can. And in a quadrilateral, we can only draw one diagonal from one corner. So when we draw that diagonal, we get 2 triangles. Now, we learned in a previous lesson, for every single triangle, each triangle adds up to 180 degrees. So in a quadrilateral, if I have 2 triangles, to find the sum of the interior angles, I just do 2 times 180, and that gives me 360. So a quadrilateral, the sum of the interior angles is always going to be 360 if it's convex. Let's try another one. Trace with me the second one. Starting from here, let's trace. 1, 2, 3, 4, 5. So a 5-sided is a pentagon. So we have pentagon. Number of sides, of course, is 5. Now look at your triangles there. We have 1, 2, 3 triangles. So if I wanted the sum of the interior angles, I simply do 3 triangles times 180 equals, and 3 times 100 is 300. 3 times 80 is 240. So 300 plus 240, that's 540 degrees. Let's do the next one. There's a pattern I want you to notice here. From here, let's count the sides. 1, 2, 3, 4, 5, 6. 6-sided figure is a hexagon. A six-sided shape. Now from one corner, let's draw in the maximum number of diagonals, which is 1, 2, 3. With 3 diagonals, we see that we get 1, 2, 3, 4 triangles. So if I want the sum of the interior angles, I simply do 4 times 180. 4 times 100 is 400. 4 times 80 would be 320. And 400 plus 320 would be 720 degrees. Now before we go on, there is a pattern between the number of sides of a polygon, so underline number of sides, and the corresponding number of triangles. There's a pattern. So look at what this pattern is very carefully. It's important you're able to spot this. We went from 4 sides, only 2 triangles, 5 sides and 3 triangles, 6 sides and 4 triangles. I'd like you to think really hard. Don't just wait for me to give you the answer, but I'd like you to try to fill in that blank. What relationship do you notice is going on between the number of sides to the number of triangles? Number of sides, number of triangles, number of sides, number of triangles. Please ask yourself, what is that pattern there from left to right? And try to fill that blank out. Hopefully you notice this pattern. 4 to 2, the difference is minus 2. 5 to 3, minus 2. 6 to 4, minus 2. So if I had an n-gon, which means an unknown number of sides, the number of triangles would simply be n minus 2. It's really important you catch that. So what do you notice? That the number of triangles equals the number of sides minus 2. This brings us to a very important, very simplistic equation. To find the sum of any interior angle of any convex polygon, all you do to find the sum of the interior is, we're going to use the number of sides minus 2 times 180. And in textbooks, the variable that's most often used for number of sides is number of sides, we use an n. So the equation you're going to most often see is for the sum of the interior angles is n minus 2 times 180. That is interior angles equals 2 times 180. Now, if I want to find, let's say I have a regular polygon, a regular where all the sides are equal, a single angle. To get that single angle, all you do is you take whatever the sum is and you simply divide by the number of sides. For example, we know to find an equilateral triangle, the sum here is 180. Is going to be 180 divided by the number of sides, which is 3, which gives us 60 degrees. So in a generic form, to find a single interior angle, you take the sum and you divide by the number. To give a more formula-based, it's going to look like this. The sum is the number of sides minus 2 times 180 divided by the same number of sides. Number of sides minus 2 times 180 divided by That's for interior angles. Now, exterior angles are actually a little bit more simplistic. Let's look at exterior angles here. I'd like you to take this polygon and we're going to sweep the exterior angles. To do that, take one side, stretch it out, and sweep. Now take this side, stretch it out, and sweep. Now take this side, stretch it out, and sweep. Keep working it around, stretch it out, and sweep. Last one, stretch it out, and sweep. All of these, when you stretch out a side, that angle on the outside, these are called exterior angles. So that is an exterior angle. And if you look really careful with these exterior angles, if we were to shade them in, they make little pizza wedges. If you were to shade them in, they make little pizza wedges. Now, if you were to take those wedges and slice them up separately, whoops, there was one more, excuse me, there's one more, sweep it, there's the purple one right here. There we go. If you were to take these angles and slice them up separately, so here would be wedge number 1, and of course 2, and the like, or going all the way around, these slices come together to form a circle. And we know all circles add up to 360. All circles add up to 360. So the simple truth about exterior angles is this. The sum of the exterior angles will always be, trace with me, 360. These are exterior angles. Exterior angles will always be 360. Always. Exterior. Always. Exterior. Some exterior angles, always 360. Now, if I wanted a single one, it's the same concept as interior. It's sum over sides. Except in this case, the sum is 360, and the number of sides is n. Now, these equations seem really confusing, but I have something that's going to help you memorize them. Go to the next page. Go back to your nursery rhyme days, and remember the nursery rhyme that goes like this. 3 blind mice, 3 blind mice, see how they run. See how they run. Ring a bell. You should kind of hum that to yourself a couple times. You want to hum that to yourself a couple times. Get the tune stuck in your head, please. Again, it goes 3 blind mice, 3 blind mice. See how they run. See how they run. Okay, you can hear it. Alrighty, let's put this together and put it math to the tune of 3 blind mice. Please listen carefully, and yes, in the privacy of wherever you're at, after I sing this one time, you will sing with me if you are a good little student. Ready? Please refrain from explosive laughter. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides ain't this fun. The sum of interior angles, sides minus 2 times 180. Now, after you've actually caught your breath and stifled a few giggles, I'm going to slow this down. I actually want you to at least say this out loud, if not sing it, with me now. I'll slow it down. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides ain't this fun. The sum of interior angles, sides minus 2 times 180. So what does this mean? Let's put this in the margin. The sum of the interior angles, so just write sum interior is sides minus 2 times 180. The sum of exterior angles will always be 360. Now, if I have a regular polygon, both of them is going to be sum over sides. Sum over sides ain't this fun, right? Sum over sides. But there's two versions. There's the interior version, and then there's the exterior version. The interior version is this. N minus 2 times 180 over n. And the exterior version is this, 360 over n. You can get a handle on these four equations. The actual in-class work is quite simplistic. Let me give you an example. So as you're working, watch out for these buzzwords. Buzzwords. Write these buzzwords down. The buzzwords are this: sum, interior, exterior, regular, is, which is an equal sign, and any to-be verbs such as are, was, were, always equal signs. The word each, and then pay special attention to the number of side words. The number of sides, such as the prefixes penta and hexa. Those are what are called buzzwords. Watch out for those. I'm going to do a couple problems with you. So, and underline the buzzwords as you see them. The sum of the interior angles of a convex polygon is 1080. What is the polygon called? So we're looking first for the sum of the interior angles. Sum interior angles is, that's an equal sign, 1880. Poly, remember, is generic. We don't know the specific number of sides, and that's what we're trying to figure out, is the number of sides, which the variables we use for that is n, for number of sides. So from here, remember back to the song which says, the sum of interior angles, sides minus 2 times 180. So we go, the sum of the interior angles is sides minus 2 times 180. And the sum of interior angles in this problem is 1080. So we're going to make these guys equivalent to each other in the right-hand side. So n minus 2 times 180 equals 1080. I'm going to wait for you to catch up. Now we want to get n by itself, so put a little arrow by n. That's where we're going. Step 1, we're going to get rid of the 180, so we're going to divide both sides by 180. (1080) divided by 180 equals 6. So we have here n minus 2 now equals 6. The 6 was that divided by that. I want n by itself, so of course now I'm going to plus 2 to both sides. So our n is 8. We have an 8-sided polygon. And we want to know what it's called, so 8 is octagon. So in this scenario, we are dealing with an octagon. Let's try another one. It says, again, underline, a single interior angle of a regular polygon is 36 degrees. How many sides does this regular polygon have? Okay, let's decipher this. First off, it's interior. Second, it's regular, which means we have congruent sides. Is an equal sign. Emphasize that. Be really careful with that. So what I have here, we want to write this out. We have a single interior angle of a regular polygon, which equals 36 degrees. Oh, 36 degrees, not 360, excuse me, degrees. So we remember the song, we want a single or each. And the song says, each angle of a regular polygon, sum over sides, ain't this fun? Sum over sides equals 360. Now we're dealing with an interior, so we have one more step here. The sum of interior angles, sides minus 2 times 180. And then sides is n again, so 360. Or excuse me, 36. I keep wanting to say 360. Now we're going to solve for n here. The easiest way to do that is simply put this over 1, and we're going to cross multiply. So we have 36n equals n minus 2 times 180. We're going to distribute. We have 36n equals 180n minus 360. I'm going to bring this over here. 36n equals 180n minus 360. So we're going to minus 180n. And here we have 36 minus 180, of course, is 144. So I end up with 144n equals 360. Okay, students, at this point I just realized that this should have been 136 after doing the math here, because this isn't going to work out otherwise. So we're going to skip this problem. So skip this one. We're going to do the last one together. It says, the measure of a single exterior angle of a regular polygon is 60 degrees. What is that polygon called? So keep in mind we have an exterior angle and it's regular. and is 60 degrees. We're being asked to figure out what is this polygon called, which means we're ultimately looking for n here, which is the number of sides. So we want to write each exterior angle equals 60. And we learned before that each angle of a regular polygon equals sum over sides. We're dealing with exterior, so our sum is 360. Our number of sides is our unknown n. But we know whatever this is, it must equal 60 degrees. So to figure this out, it's simply 360 divided by what equals 60. Put this over 1, we cross multiply. We have 60n equals 360. We divide both sides by 60, and we know, take the zeros off, 6 goes into 36 6 times, so n, the number of sides, is 6. And what is that called? A six-sided shape? That would be a hexagon. Hexagon. Now, as far as the U-try, I'd like you to go ahead and skip that. We're going to do these in class instead.